Thanks for the introduction. My name is Balázs Bucsai, and I'm going to talk about XFLTReaT in a bit. But first, let's start a few words about me. I'm a Hungarian hacker just around the border, but I live in the UK and work for NCC Group as a senior security consultant. I just moved there a year ago, and I started to do low-level IT stuff when I was 13 years old. I started with Ringo debuggers and disassemblers. I had totally no idea what I'm doing, but I really enjoyed it. So that's how I started. I have some experience in IT security since that, and I have some strictest technical certificates listed on the slide. I'm going for the CREST CCT next month for the technical part. Hopefully I will pass it, fingers crossed. And I had a few major projects in the past, like for 2 years ago. For example, 2 years ago, I did a research on SiegeRoot. I created a tool, it was called SiegeRoot. It's on GitHub, and I had a presentation about that here in DeepSec, so I'm a returning speaker. Thank you for inviting me again. It's a pleasure to be here. And last year, December, I started to do my new research, which is XFLTReaT or XFLTReaT. I already had this presentation on several other conferences, and this is the last one for a while, I guess. There is my Twitter handler, which is X or EIP. If you like my presentation or the tool, please follow me on Twitter. And the LinkedIn profile, my LinkedIn profile is the last link, the only link on the slide, if you like. Like I already mentioned, I had some presentations around the globe. I just came back from Australia, from RocksCon last month. I had the same presentation, almost the same. I always slightly changing it in Singapore, in the Hack in the Box, and on Hawaii in the US, and on BrewCon in Ghent. And I had other talks on different conferences already. So about this presentation, if I need to summarize the whole stuff in one word, I would say tunnels. So first of all, and not exfiltration, and I will explain that in a bit. So it's more about tunnels and not really about exfiltration. First of all, I would like to have a question for you, ask a question. Do you know what tunnels are? Please raise your hands if you do. Okay, many people. Do you know have you ever used Cisco AnyConnect? Please raise your hand again. Yeah. OpenVPN maybe, raise your hand. Yeah, so you know what tunnels are. For those who don't know what tunnels are, here's a little figure. This is like how the internet works. On the left-hand side, you have your computer, which is connected to your router, to your modem, that is connected to the internet. And on the right-hand side, you have two servers. One at the top, that doesn't really matter right now, and the other one that has all your cat videos, because you love your cat videos and you want to watch them all the time. So whenever you want to watch them, you just connect to that server over FTP, for example, which is essentially just TCP, and you connect. After you connect to it, you download all the stuff. Whenever you download it, and because the FTP usually is not encrypted, all the internet hops, like your router, your modem, and the other routers on the internet, which are between you and the server, are capable to inspect your packets, so they will know your original IP address, your destination IP address, and what you are transmitting, because it's unencrypted, right? That's a kind of an issue, but that's how the internet works. But if you are using tunnels or VPNs, then usually your data is encrypted, and you have a dedicated connection between your two endpoints, your computer and your VPN server on the right-hand side on the top. So you have this dedicated connection, and you send everything over that connection. Whenever you want to download your cat videos, you first go to the tunnel server, your VPN server, you send all the data there, it will forward your data to the server, and whenever there is an answer, it will forward the same, it will send the data back to the VPN server first, and then to the tunnel endpoint over the tunnel. So that way, between you and the tunnel server, or your VPN server, the data will be encrypted if your VPN solution is supporting encryption. And whenever you download your cat videos, the server that has your cat videos will only see the IP address of the VPN server, and the internal hops will only see, between you and the VPN server, they only see that you are communicating with the VPN server. So this is how tunnels are working. So why would you use VPNs? First of all, because you want to work remotely and you need to access your company's resources. So you connect to the corporate VPN, and for example, you can access that then a file share, and it's just like that you are in the office and you can work remotely. Or you want to hide your real IP address because you are doing BitTorrent, or you are a whistleblower, or a journalist who wants to report news anonymously. I personally used VPNs for different reasons. For example, my ISP was filtering some ports, so I had to circumvent that. I set up an open VPN on my server. I went over that, so I had full access to the internet without any filtering. But usually with VPNs or tunnels, you can bypass corporate proxy policies or captive portals. But there are many other reasons why would you use VPNs, but this is just a few. I have a few more questions for you. Have you ever used any VPN tunneling solutions that use TCP as a transport protocol? Please raise your hands again if you did. Could you give me 1 or 2 examples? Not really. OpenVPN or Cisco AnyConnect, those are 2 really famous examples. Have you ever used UDP for tunneling? An example? Yeah, OpenVPN. ICMP, what about ICMP? Raise your hands, please. It's an exercise. Okay. Could you give me an example, maybe? No, not really. Hence, speed tunnel ICMP TX. Have you ever used, sorry about that, have you ever used DNS? I guess that's really easy. Any famous tools? Okay, that's one. But Iodine, I guess that's the most famous, and that's reliable, and that's really good. If you want to use HTTP Connect, like if you want to go over a proxy, then you can use Proxyfire, or even OpenVPN supports that. But if you want to use pure HTTP, that's getting a bit harder. There are some solutions, but it's not easy to find and it's not easy to configure. If you have a proxy that supports only TLS version 1.2, for example, for some reason, it's even harder. And I'm more than sure that you can't find anything that supports TLS version 1.2 with Kerberos authentication when you have a proxy like that. It's just almost impossible. You need to write your own tool. I really like to travel, and last year I went to Africa, to Morocco from Italy. I took a ferry. It wasn't like cruise. It wasn't nothing like this. I had a really small cabin with no windows, and I was really bored. I didn't like to be bored, so I realized there is Wi-Fi. I connected to it, and then it turns out that I need to pay for the internet, which I really don't like to do. So I started to poke around, and I realized that the port, what we are using for HTTPS usually, port 443, on TCP was unfiltered. So if I have set up an OpenVPN server, for example, on port 443, then I could have unfiltered internet access for 2 days, but I didn't do that, so I was bored for 2 days. Then next time I was flying to Japan from Hungary, which is about 10 hours, and the same thing happened to me. The flight had a Wi-Fi. It was really expensive again. I wanted to do something, so I started to poke around, and I realized that ICMP is working on that network that wasn't filtered. So I could have done ICMP tunneling, but I forgot to set up my ICMP tunneling tool, so I didn't do anything. I was bored for 10 hours. And this is coming back to me, like every time I go to an airport, because on airports, the DNS is usually unfiltered. You can do DNS tunneling. And I always set up my tool, but it crashed, or I had some other problems with it, so it wasn't working at all. So I got really upset. So I started to compile this list with all my issues about tunneling. Like, if you want to use more than one protocol, usually you need to install more than one tool. It's like as many protocols, as many tools you need to install, which is not that kind of nice, because you need to configure them, It's not that easy. Usually there is no documentation or whatever, and they use different configuration all the time. All the tools or most of the tools are proof of concepts. So the guy just wrote one, it was working for him. Probably he can or she can modify it anytime, but you are stuck with it. And if it's not proof of concept, it's usually end of life or unsupported already. So even if you find the bug and you report it, nobody cares about this because they don't support it anymore. So you can fix it yourself, but the languages that are written in, these are different. So you need to know the language. Maybe you need to have some experience in that language to fix it, and in the networking as well. And it's just reading other people's code, usually awful. So you don't like to do that, I guess. I certainly don't. And that's it. So basically, it was hard to do tunneling before this, but it doesn't have to be hard because it's quite easy. So this was when my beast was born, which is XFLTReaT or XFLTReaT. Doesn't really matter for me how you say it. And that's when I started to write it. So before I started the stuff that matters, I would like to give you a lecture about tunneling. So this is Tunneling Theory 101. On the right-hand side, you have the Matryoshka dolls. These are kind of Russian dolls. And what you can do with this, you can put each and every one into another one. And at the end, you will have only one. So you can do the same with tunnels. You can have one tunnel, you can put it into another one, you can put it in the third one, to a fourth one, and you can do it as long as you want, which makes no sense after a while. But if you do it like once or twice, that makes perfect sense. Because tunneling works like this. You have a network where you connect it to, and they filter everything. They have firewall rules that filter out TCP and UDP, for example, but they forget about ping requests and responses, so ICMP. So what you can do on that network, you can just set up a tunneling client on your client, and you need to set up a tunneling server outside of that network. And what you will do, you capture all the data, all the packets on your computer with your interface that was set up by that tool. You capture those packets and you put it into another packet, like an ICMP, like a ping request, because you can send pings, okay? And whenever you did that, you can send it over the internet because that's unfiltered. That's not filtered at all. So you send it to the server will get it. It captures the ICMP packet that you sent. It decapsulates the TCP packet or UDP packet or whatever from that transportation protocol, which is the ICMP. So after that, you will have the green packet again, which was your original packet, and the tunnel server, your VPN server, will forward that to the original destination. When the original destination, that server answers to your packet, the server side, the VPN server, will capture that again with the interface. It will put it in, it will encapsulate your packet into an ICMP response, a ping response, and send it back to the client over the internet. And again, because ICMP response is unfiltered on the network, you will get it, you decapsulate the packet over your interface with your stuff, and you will get the original packet. So that's how you circumvent the firewall. That's how you communicate with your server outside of your network. So what's XFLTReaT? It's an open source tool. Actually, it's more than a tool. It's a framework. It's Python based. It's object oriented. It's modular, multi-client, and so on. So it's really easy to use. At least I think so. So if you go to the GitHub and you clone it, you install the requirements, edit the configuration, you just configure it properly, and you run it, and that's it. It should be good to go. All the tunnels, the encryption, and the authentication stuff are modular. So whenever there is a new module introduced, you should be able just to copy it to the right directory, edit the configuration, rerun the tool, and it should be working. It's a framework, it's not just a tool. I like to say that because it does a little bit more than that. When we are talking about tunneling, it's basically you need to pack all your packets into another type of protocol, and you need to get the data from that protocol. That's basically tunneling. So you need to know how to encapsulate and decapsulate your data, and how you send your data over the network. That's the 2-3 things that you need to know about tunneling when you want to do that. At least you think so. But if you ever try to you write your own tunneling stuff, your own tunneling tool, you will see, or you already saw, that there are lots of other things that you need to implement, and it has nothing really to do with tunneling. Like, you need to set up an interface, set an IP net mask, set up the routing table. If you want to handle multiple clients, then you need to do that. If you want to do authentication, encryption, encoding, that kind of stuff, you need to do that as well. And it's not really about tunneling. This is not about the core stuff. You don't want to care about that because that is written by others, like so many times that was written by others. So this is a framework because it handles all these kind of stuff. You only need to really think about and do if you want to do your own module from this framework, you just write your own module and all the other stuff will be handled by the framework. I think the best functionality of the framework is the check functionality. It's really easy to use. I'm going to show you during the demo. What it happens here, that the framework generates a challenge, and it will send a challenge over every enabled module in the framework to the server. If the server responds to the challenge with the right result, then you will know that you will know 2 things. First of all, there is an XFLTReaT server on the other side, and that tunneling protocol that you are using at the moment, that will work. So probably you can build up a tunnel because there was an answer, so you managed to communicate with the server, right? Back in the time when you use different tunneling solution on your server, you had to install, like, I don't know what you were up to, but in some cases you had to install like 2, 3, 4 different tools. So these tools, after you configured, set up 2, 3, or 4 different interfaces. This is not the case with the XFLTReaT framework anymore, because it is using only one interface with one IP, with one IP pool. So it's kind of easy. You don't really need to configure about that anything. So this is the server side. This figure shows the server side. On the right-hand side, we have the internet. The clients are connecting from that side, and over the yellow line. If you think about the same scenario that I already explained to you, when we have a network and everything is filtered except ICMP, except ping, then we are talking about the little purple box, the ICMP box at the bottom. The client sends ping requests to the server, so that will come in over the yellow line to the ICMP box. The ICMP box will decapsulate the packet from the ICMP request, send it to the tunnel interface. The tunnel interface will do some readdressing, and after that, it will send it to the kernel. The kernel will do the forwarding. It will send the original packet to the server, to the original destination. And whenever you had that, you will get an answer from the server. It comes back. It will be handled by the kernel. It will send it to the tunnel interface over the green line. And at that point, the XFLTReaT framework or the tunneling solution needs to decide where to send it to. So there is the packet selector module that I wrote. It will check the header. If the IP matches, it will send it to the right module, to the ICMP in that case. And it will encapsulate the packet again and send it back to the client over the internet, over the yellow line. So this is how it works, really. In every tunnel that you create with this tunneling solution, you have 2 channels. First of all, you have the data, which is obviously used for data transmission. It is used for transmitting the IP packets that you are sending. And the other one is the control. It is used for control messages. Like there is the check message that I already explained to you and I'm going to show you. When you send this challenge, and the check response, when you get back the response, authentication, encryption related stuff, and when you log off from the VPN, and other stuff is handled over the control channel. It's kind of easy to develop for if you know what to do. It's not just 5 minutes work. You need to understand what you are doing, but it is a lot easier than it was. And this is the module 3 what right now we have in the XFLTReaT. So there is the generic module. So the full stuff is object-oriented, or like 99% of it. The generic module has all the methods and properties that are shared, that are used between all the other modules. And there is a split because we have 2 different kind of protocols, like stateful and stateless. TCP is stateful, UDP ICMP is stateless, and these needs to be handled in a different way, in a different manner. So that's why we have a split there. In the stateful module, you have everything that is related to stateful modules. In the stateless, you have everything for the stateless modules. And these 3 modules, the generic, stateful, stateless, are just, I like to call them skeleton modules because they don't really give you features or additional functionality. These are just the base of the other modules. So because it's object-oriented, and when you create a new module, it will inherit the parent modules, all the parent modules, methods and properties, because that's how OOP works. And basically, you will have everything in the module that was already implemented in an upper module. For example, if we take a look on the TCP, what it does, it just creates a TCP connection between the client and the server, just like OpenVPN, and sends all the data over that TCP stream. If we are taking a look on HTTP Connect, that's almost the same, but it includes a proxy support. So whenever you have an HTTP proxy on your network, which supports HTTP Connect method, then you connect to the HTTP proxy, you send the HTTP Connect method to connect to the server. The proxy will connect to the server, and that's the way how it will build up a TCP stream. So basically, from that point, when you have the TCP stream, it's exactly the same like the TCP module. And there is no reason to re-implement all that functionality. So that's why I use object-oriented programming, because I just inherit all the stuff. And in this case, the TCP module is about 350 lines long, and the HTTP Connect is 150 only. So I'm not sure if you can show me another solution which implements HTTP Connect functionality in 150 lines or less. At the moment, we have TCP, HTTP, SOCKS proxy support, HTTP Connect proxy support, and WebSocket over proxies, ICMP, UDP, and DNS. DNS supports only 3 different record types, but that's easily extendable. But that's a proof of concept. The DNS is a proof of concept, so it needs to be developed. It's a bit of struggle. So if you want to use the tool or develop for, it's kind of easy. For example, if you have a network where everything is filtered, but port 80 HTTP is allowed, then you just bind the XFLTReaT on port 80, and you are good to go. If you have a network where the ping request is filtered, but the ping response somehow isn't, you just copy the ICMP module, change the type 8 to 0, and you are good to go. If you have some kind of inspection, IDS, IPS, or proxy on the network, and it requires a special header, in some cases there is a need for that, then you just copy the HTTP module, set the header in the source, and all the requests will go with that header. If you have a proxy again that supports HTTPS only over TLS version 1.2, then you just set TLS version 1.2 strictly in the source file, and you are good to go. If there is some kind of special authentication like Kerberos, with what is needed over the HTTP proxy, you create your Kerberos authentication module, and you just insert it into the framework, and you should be good to go. That's the theory part. This is a theory part, but it is going to work, and Kerberos authentication is not that easy to do, but there are some Python-based Kerberos authentication out there already. If you want to do out-of-band tunneling, like you have 2 mobile phones and you want to send all the data over text or SMS, you can do that. You need to figure out how you connect your mobile phones to your laptops or to your server, how you send and receive text. You implement that in a module, and it should be handled by the framework. I'm going to write the documentation. I'm always telling this, but I think the implementation is a bit more important at this point, but I'm going to do the documentation. But even if there is a documentation, I really recommend you to read the source if you want to develop for the framework, because that helps you to understand how it works. When I started to do the implementation at the beginning, I wasn't confident about the whole stuff. I wasn't sure that it will work with all the protocols and all the scenarios. But just after a week, like two months ago, I released a tool on a different conference. And just after that, a guy came, Infodocs from Twitter, he sent me a pull request over GitHub. He created this SCTP module, which is quite nice because he had no questions. It was working like almost out of the box because I had to move it in an X version branch, whatever. So it was working, and it's really nice because I want this as a community tool, and it would be nice to get you involved. A month ago, I had a different job for a bank. I had to test proxies, and some of the test cases involved tunneling. So I just figured out maybe I can use WebSocket for that. So I created my own WebSocket module in 3-4 hours, and it worked. I managed to tunnel data over the proxies with WebSocket. So if you want to participate, I really encourage you. Please help me because I need help. It would be nice to have more modules, more functionality in the framework, or whatever. I have some other ideas as well. So if you want to, if you know Python or you just want to learn, but you want to do something about this, please come to me after the presentation over Twitter or just send me an email. Please use the next version branch over on GitHub because the master branch is a stable beta, and it's a bit old, and all the new functionality and maybe it's a bit broken, but that's in the next version. So the next version is under development. It can be broken anytime, but that has the cool functionality. So this is the demo part, and I need to hurry a bit because I was talking slowly. So this is my server in Amazon, and what I do here, after I cloned the repository, I configured it already. I don't want to bore you with that. And I just specify the server stuff. So that way I run the server on the XFLTReaT server on my server. The HTTP connect is not working because that port is already used, but that's fine. We are not going to use that. And this is my Kali Linux. And I'm not sure that you can see that properly. Is it better now? Can you see it now? Okay, that's a kind of yes. So this is the configuration. It's kind of straightforward. Maybe it's just straightforward just for me. If you have any ideas, I'm happy to hear. So this is the remote server where you have your XFLTReaT server. This is the server configuration. You don't really need to touch that, not really on the client. This is the client configuration. You don't really need to touch that either. Maybe if you have an IP conflict. Authentication, it's really basic now. It's sorted SHA-512. It's a shared key stuff. Yeah, and then you have all the modules like TCP generic. It's enabled. That's the server port, so it will connect to that. UDP generic is the same. ICMP is enabled. SOX proxy, the proxy IP is 1111, which is not going to work right now. It's just showing you HTTP connect is the same. That's not going to work. DNS, SCTP, WebSocket. So that's the configuration. Everything was enabled. So what we do check functionality because we don't know this network, right? So just like this, DNS is working because that's green. It should be working. HTTP connect is not working, obviously, because the IP was set to let's say, a fake one. ICMP is working. SCTP is not working because it's nutted, and VMware is not handling that. SOCKS, same reason. TCP, UDP is working. WebSocket is not working because it is using a proxy, but I didn't set a proxy. So we go back to the configuration. We turn off everything, disable everything except DNS because we are going to do DNS. Wow, 10 minutes. So this is a proof of concept module. DNS is for tunneling is a bit tricky. Yeah, and lossy. So we just start Wireshark here. And instead of check, we will use client verbose too. I want to see what's happening here. So this is doing an auto-tuning. If I have time, then I'm going to tell you, but not right now. It finds out which is the best record type and way and encoding and that kind of stuff to send packets. And let's go to here, open this web page and go there. And as you can see, everything is going over DNS, nothing like TCP, UDP, nothing like that. It's already loaded. That's my employer. And if you download stuff, I'm not sure you can see that, but it's really good actually. It's 130 kilobytes per second, but I use my own DNS server for this. So you know it's 100, it's going down now, it's scaling up and down. Okay, let me just close this way. Okay. You know, it's usually not that good, but if you have your own environment, then it can be better. I tried yesterday here, it was working very well. Because, you know, there is a captive portal in this place. Oops, not that one. So I just changed the configuration to ICMP. So that's, you know, it's really easy. That's the point. You don't need to install a different tool. You just change the configuration if you have the right module, and you can do that. ICMP should be working. So we just do the same stuff, client, and it's sending the data already. So let's open this page. As you can see, it was very quick. And everything is going over ICMP except ARP, but that's a different level. That doesn't really matter to us. And the speed right now, 300, 400 kilobytes, 500. It's scaling up and down again. You know, everything is going ICMP here. You know, there is nothing new about tunneling. I'm not showing this to you because the ICMP tunneling is a big thing. I'm showing this to you because there is a tool now that you can use, like a, I don't know, you can use everything in one, and you can even develop your stuff for it. So the next thing that I want to do, and I already did, last weekend I introduced the Mac OS X support. Probably it's working with Mac OS as well, not just Mac OS X. TCP and UDP working very well. ICMP is only client mode, because in Linux you have this ignore ICMP stuff when the kernel ignores all the ICMP packets and doesn't transfer to it. But in Mac OS X and then BSDs, there is no option like that. At least I couldn't find it. So even if you send a ping request, it will be answered by the kernel. So if you want to answer it from your implementation, you can't do that. So that's why you can't use ICMP in a server mode. The next stuff that I'm going to do, probably in the next weeks, hopefully not in the next month, is the Windows support. So you will be able to use most of the modules over on Windows as well. Linux is fully supported at the moment, and the big dream right now is to write an RDP, a terminal services extension, that can be used to do testing. Like whenever we do a penetration test, and the clients come to us and tells us that, yeah, you need to do that over an RDP server. But that really kills the whole situation, because you can't really do scanning only if you install all your tools on the server, but kind of hate to do that, right? So with that, you only need to install Python, the requirements, and XFLTReaT, and you should be able to do a tunnel between your client over the RDP protocol. It doesn't require any other stuff, and you should be able to scan. So the tool can be used for offense and defense as well. The offense part is my favorite. Let me start with that because I do that on a daily basis. You can bypass basic and not that basic obstacles. For example, if you know that DNS, ICMP, whatever is allowed, you just set it up like that. If it's not that basic, then you need to figure out what kind of protocols are allowed. You need to implement that module. If there is a special authentication like Kerberos is needed, then you need to do the Kerberos authentication part, and so on. You can exfiltrate data, but if you exfiltrate data, that's not going to work out very well for you because it's a noisy stuff. It creates a full tunnel. All the packets will be sent back and forth. It's noisy. If you want to exfiltrate, you need to find another tool which is more healthy, slow and that kind of stuff, and undetectable. Probably it's detectable. And my best reason to use it to get unfiltered internet access in lots of places. For defense, try to use the check functionality. You can figure out if there is a vulnerability on your network, and you should try to exfiltrate data. First of all, you should be the first one, because if not, you are not the first one, you already had a breach, and that's not nice for you. And the other stuff that you can test your SOC team with this, if they are able to figure out what's going on and they are able to detect it, that's really cool. If you have a captive portal like a guest network on your network, then you should drop all inter-client communication. You should drop all the packets that are externally addressed, so you shouldn't allow anybody from the guest network to access the internet until they are not authenticated. And you should rewrite all the DNS responses to the captive portal's IP. And that way, when the guest opens the web page, he or she will see the captive portal, and after authentication, you can drop all these rules. You can give unfiltered internet access if you like, but the point here to get the user authenticated. So unfortunately, I don't have a 100% secure solution for you, but this is the best what I can do. So if you have a network that you are responsible of, or for your company, for example, you shouldn't route anything to the internet. You should have a set of proxies. Those set of proxies should have unfiltered internet access, and you should whitelist the ports, like port 80 and 443 should be enough for all the applications and for everything. And you can blacklist sites, but that's not going to help against exfiltration or XFLTReaT. And you shouldn't do any external DNS resolving. You should have a set of DNS servers just for internal addresses. They should be able to resolve internal addresses, not external, because that way you can fight against DNS tunneling. And you should enforce the proxy policy on all computers, including servers. Like 99% of your company should go over the proxies. It's not easy to implement, I know very well, but you can do that. And there is 1% that won't be able to use the proxies, of course. That's fine. That should be an exception list. You can give internet access to them, but 99%, I would say, of your company should go over the proxy. You should have an inventory. If you don't, you should start to do that right now. It should have the IP, the location of the box, the owner of the box, the purpose of the box, and the contact number to the owner at least. If you have your own inventory, you should do baselining with NetFlow or Bro and Bro. With that, you can create a statistical map of your network. You identify the top talkers, the IPs that are talking to each other, the frequency, the volume, the protocols, and that kind of stuff. And you create this statistical map, and after you feel confident about that map, you just put it in alert mode. Whenever you have this in alert mode, you will get probably lots of alerts. Half of them will be, or maybe more, will be false positive. That's fine, you just add it to the statistical map. And after that, if you have other alert that can be malicious, then you know who to call, and they can just isolate the box from the network, and you can start your investigation. The tool was already released. There is 2 URLs here, XFLTReaT info, it's easy to remember. It's basically just a placeholder, and the other was the GitHub repository. That's a bit harder to remember, but you can get it from there. To do, yeah, I'm always telling this, I'm doing this. Actually, bug fixes all the time, commenting, that's as well. There is no encryption at the moment, I'm working on that. I want to do something proper encryption because you know, you can't really, it's better to have no encryption than a bad encryption, I would say. So thank you for your time and your attention, and I think I'm out of time.
Thank you very much.
Thanks.
There would be time for one question.
You mentioned that the DNS tunneling module is a bit messy. Why is that?
Yeah, that's a long story. How many minutes do I have? Just a few? Okay, so just, that's Linux only, first of all, because of different reasons. And I just need to figure out fragmentation and other stuff, and it's not easy to do because DNS is kind of easy to understand, kind of easy to implement, but whenever you do other stuff than DNS itself, like tunneling, then it starts to get messy because there are lots of different implementation. They follow the RFC in a different way. You need to be compatible with all the implementations, and you know, it's UDP, so it's lossy sometimes, and you need to track these packets that's not implemented. So I wouldn't say it's a full release. It's working for me most of the time, but not always, and I don't feel comfortable with that.